You too. And next up, we're going to hear a panel discussion from scientists and authors of the IPCC report. And the session will be led by Stefan. So the topic will be about understand and apprehend the latest IPCC report on climate change, the physical science basis, and the climate politics. And the three speakers we're going to have is Nicholas, the co-author of IPCC report, Ella, climate scientist at the University of Reading, and Stefan, a researcher on the politics of climate change and environmental justice. Now, Stefan will be the moderator for the panel discussion, and the stage is yours, Stefan.
Thanks. Guys, my name is Stephen Lezak, and I'm very happy to be moderating. I'm sort of giving my own spiel in an hour or so, so I just want to turn it over right away to Ella and Nicholas, who are going to give us some background on the latest AR6 from IPCC, and then we'll go into a conversation about that. Ella, do you maybe want to start?
I think I will start.
Great.
Let me try and share the slides. Okay. Stephen or Ella, can you confirm you're seeing the slides? Okay.
Yes, I can see them. Thank you.
Perfect. Let's go then. Hello, everybody. My name is Nicholas Berwin. I'm a professor of climate processes at the University of Reading in the UK. And I was one of 234 authors of the latest 6 assessment report of the IPCC that was published in August. So when I say IPCC, I should say the first working group of the IPCC, because there are 2 other working groups. We will publish their reports, I think later in the year and then next year. So working group 1 is about the physical basis of climate change. So it is about our physical understanding of climate changes. So just to give you an idea of the process, so the assessment reports essentially assess published scientific literature. And the idea is to identify the aspects of climate change that we know best, and those where confidence is more limited. So it is done by assessing scientific publication, and for the latest report, 14,000 papers have been assessed by the authors. And once that is done, there is a series of iteration with reviewers, so scientists all over the world, who make comments on those reports. So this time around, we received more than 78,000 review comments, which had to be addressed and answered individually. And the reports improved in that way among the different drafts. And finally, a lot of what we're going to show today comes from the summary for policymakers. So this is a very short document that summarizes the report. The report itself is about 4,000 pages, but the summary for policymaker is much shorter. I think, I don't remember, maybe 20 or 30 pages. So not many details, of course, in that summary, but all the headline statements that gives you the essence of the report. And this is what we're going to cover with Ella. So I'm going to cover the past and the present, and Ella will talk about the possible futures, because there are many that are possible still. So if we get started on the first headline statement, so the report concludes that it is unequivocal that human influence has warmed the atmosphere, ocean, and land. This kind of statement is supported by an analysis of human influence on different aspects of the climate system. So this is summarized here by this figure that shows a few key changes in the atmosphere at the top, the ocean on the left, land at the bottom, and ice on the right. And for all those changes, which are either decreases or increases or changes depending on the region, the report assesses whether human influence is the main driver, so that's a red tick, or an important contributor to the change. And you see that, not very surprisingly, human influence is the main driver of very important changes. For example, surface temperature, sea level rise, the changes in precipitation, and the decrease in Arctic sea ice. Another headline statement is that the recent changes that we've just seen are widespread, rapid, and intensifying, and unprecedented in thousands of years. So this unprecedented aspect comes from this kind of figure that shows the temperature change as a function of time from 80 to all the way to the present. So for the earlier periods, you can those temperatures have been assessed using paleoclimate studies, reconstructions using, for example, tree rings or sediments. And since about 1850, we have instrumental record, which is here in black. We are now at plus 1.1 degree warming with respect to the period 1850 to 1900. And if you go back 2000 years, you see that the current warming occurs at a rate that is faster than any other period over the past 2000 years. And there are uncertainties on what happened before. So this is a bar here on the left that shows warming over the last interglacial period, 125,000 years ago. But it is plausible that our species has never experienced such temperature in its existence, and certainly since the start of civilization. Next headline statement is that it is indisputable that human activities are causing climate change and making extreme events more frequent and severe. So extreme events changes are summarized here. That's the assessment. Extreme heat has become more frequent and more intense in many regions. Same thing for heavy rainfalls. Drought has increased in some regions. Higher weather has become more frequent, and oceans are warming, acidifying, and losing oxygen. Climate change is already affecting every region on Earth in multiple ways, and the changes we experience will increase with further warming. This is illustrated by this assessment that shows the distribution of warming with respect to 1850 to 1900 for 3 different global warming levels: 1.5 degrees, 2 degrees, and 4 degrees. Red colors show warmer temperatures. And you see that at 1.5 degree, many regions, in fact, are much warmer already than 1.5 degrees. The Arctic is warming much more than the global average. And in general, land surfaces warm more than the ocean. And this is true at 2 degrees and 4 degrees. So even though there is a number for global average warming, that doesn't mean that everybody experiences the same level of warming. Precipitation changes also scale with warming. We see the same distributions, but now for precipitation, change in percent, wetter is in green, drier in brown. And you see that 1.5 degree, some regions start becoming experiencing less precipitation, and some regions more. And those patterns essentially become more pronounced as warming increases to 2 degrees and 4 degrees and further. The same can be said for soil moisture. So this is what is related to flooding and drought. Here again, wetter is in green, drier in brown. And you see that in at 1.5 degrees, and we're not too far, we are already at 1.1. Some regions are drier, for example, the Mediterranean basin here, and other regions like Central Africa and the Central Asia will experience more soil moisture. So since it is yes, Europe, let's look at the regional fact sheet for Europe. So the IPCC Technical Support Unit makes fact sheets, summaries of the assessment for different regions. You will see the list here on the left. And this is the one for Europe. And you see some key facts about the region. It is warming at a larger rate than the global average. Precipitation has increased in Northern Europe in winter and has decreased around the Mediterranean in summer, and that decrease is extending northward, with warming. And also notable is that the relative sea level rise around Europe is larger than the global mean sea level rise. So I now give the floor to Ella, who is going to talk about future.
Thanks, Nicholas. So we've seen the kind of extent of historical and present climate changes, and we've seen the magnitude of what's happened already. And unless there are immediate, rapid, and very large-scale reductions in our emissions of greenhouse gases, limiting warming to 1.5 degrees or less will probably be beyond reach. And this is quite a damning statement in some ways. Next, could you move the slide along, please, Nicholas? Thanks. So here we've got a time series going from 1950 to the end of the century in 2100. Again, we're looking in terms of temperature changes. So this is relative to the period 1850 to 1900. And the first part, which is in black, is historical changes to date. So you can see that it goes up to around 1.1 degree, as Nicholas said. Now, the colored lines are these scenarios which the IPCC used to project into the future. And these are various different scenarios, different possible futures that have different levels of greenhouse gas emissions and therefore different levels of warming by the end of the century. And these range from low and very low in the kind of blue colors on the right-hand side, those are at the bottom, all the way up to high and very high in the redder colors. And we can see that within the next sort of 20 to 30 years, the near term, most of those scenarios have the same sorts of amounts of warming, but that as we go through the century and we go through the time, if you could press forward, please, Nicholas, then those scenarios start to separate out, and the actual warming that occurs starts to spread out. So the highest emission scenarios have much more warming in the midterm, so 2050 or so, than the lowest emission scenarios. It's also worth noting here that only the two lowest kinds of emission scenarios are able to limit warming to below 2 degrees by the end of the century. And even in the case of the very low scenario, warming may temporarily exceed 1.5 degrees before declining back below that point by the end of the century. So if we go ahead, yes. This is a really important point, that every single ton of CO2 emissions or greenhouse gas emissions adds to the amount of warming that we see by the end of the century. So this is another sort of way of looking at the same thing, except instead of considering time here on the bottom x-axis, we're looking at cumulative or increasing CO2 emissions. So again, we're considering increasing temperatures, but we're looking at how ongoing emissions actually contribute to raising those temperatures. So in the lowest emission scenarios, so those are the blue colors, remember, the cumulative emissions will peak and finish at a much lower level, and that will translate into lower temperature increases by the end of the century. So this really emphasizes the point that every single emission, all the emissions of CO2 and greenhouse gases contribute to warming the climate, and that higher cumulative CO2 emissions result in higher end of century temperatures. So if we could move on. Now, this is a fairly stark point. There is no going back from some changes in the climate system. So many changes are already in a way locked in because of the historical emissions that we've already put into the atmosphere. So sea levels will continue to rise, even if by some magic tool we stopped emitting greenhouse gases tomorrow. Sea levels would continue to rise for decades. But lots of these changes are going to continue depending on the scenario that we end up following, because of course emissions are not going to stop tomorrow. And these are particularly true for changes in the ocean and in the ice sheet. So the chart that we're looking at here on the left-hand side is the change in global mean sea level relative to 1900. And it's a time series from 1950 all the way to the end of the century. And by now you will be familiar with the color lines of the scenarios. Now, one of the things to note is that this kind of euphemistic term, maybe low likelihood, high impact storylines, which is essentially very catastrophic changes or very dramatic changes that are potentially less probable, but would have huge consequences, are also assessed, and they cannot be ruled out. So we need to consider the possibility that the complete collapse of the West Antarctic ice sheet or the Greenland ice sheet, for example, could occur and would result in absolutely enormous amounts of sea level rise by 2300, which is what you can see on the right. So under these sorts of low likelihood, high impact scenarios, which is the dashed line, you might see 2 meters of sea level rise or thereabouts by the end of this century. But if we fast forward 200 years further, it could result in 15 meters of sea level rise. And that cannot be ruled out if we continue to emit huge amounts of greenhouse gases. So again, this underlines the importance of avoiding those highest emission scenarios if we are to avoid the most significant changes in the climate system. So having said that, some changes can be slowed down and stopped by limiting warming, and strong, rapid and sustained reductions in greenhouse gases are both necessary to limit warming, but would also reduce the consequences of climate change and bring about other positive changes, such as in air quality. So if we move along. So here we've got some bar charts which are separated into those 5 sort of families of scenario again. So we've got the kind of lowest temperature ones on the left, all the way up to the highest emissions and highest temperature rise scenarios on the right. Again, we're thinking about temperature change. And this is the contribution to total temperature change from different emission sources. So from CO2, from greenhouse gases other than CO2, things like methane and nitrous oxide, and then the contribution from aerosols and land use. And you'll notice that in all of those scenarios, the potential contribution from aerosols and land use is actually negative, and that CO2 is the most important driver of those temperature increases, but that there is also an important role to play for greenhouse gases like methane. So in all of these scenarios, it's also important to just say that any climate benefit is also complemented by benefits to reduced or improved air quality, essentially. Sorry, thanks. Thanks, Nicholas. Now, this point is really important to finish on. What we do now matters so much. The climate that we end up getting in the future, the climate that we all end up living in the future, depends on what we do now. So our decisions now and our actions now cannot be more important. So if you want to look at the actual science of the report, the summary for policymakers that Nicholas was mentioning at the very beginning can be found at this link. Recommend skipping through the figures at least if you're interested in any of these topics. And there's also a really fantastic tool which brings together a huge amount of information called the Interactive Atlas, and that's also on the IPCC website. So if you're interested in any of that and want to delve into the details, then I'd recommend having a look at both of those.
Ella and Nicholas, thank you so much. I want to just ask, is there anything else you'd like to add before we go into a quick question session?
Not from me.
Great.
Happy to go to the questions.
Perfect. Well, and I just want to say, since I first really started working on climate change about 10 years ago, the IPCC physical assessment report has become kind of this this sort of ritual of reading. And I remember first reading AR4 when it came out, and it's interesting watching the physical science evolve along with our politics. And for those on the call today, I recommend scrolling through the executive summary, the summary for policymakers, because it does contain a level of detail that gets lost if you're just reading the news, for instance. And it's, I think, important for all of us, even as social scientists, even as policymakers or analysts, to be able to really root ourselves in the physical science. With that out of the way, I want to start with a sort of bleak question, which is that AR6 comes out very clearly and says that there is a low likelihood, is its terms, that we will achieve our goal to limit warming to 1.5 degrees. And in the last 3-4 years, we've evolved a very robust policy language around 1.5 degrees as this important target. And the question I have for both of you is, do you think, and I understand that neither of you can wade too deep into the politics here based on your affiliation with IPCC, but do you think it's time for us to recalibrate and to speak to a target other than 1.5 degrees?
Maybe I can start on that one. So there are different aspects. First, there's the physical aspects of whether physically it's possible to stay within, well, under 1.5 degree warming. And the report says, yes, there's nothing in the climate system that prevents us from staying under 1.5 degrees. But of course, the devil is in the details, and the detail are the scenarios. And very few scenarios stay under 1.5 degrees. Some go just over, and maybe 1.6, 1.7, and then go back under. But the problem is that those scenarios are very optimistic on our capability to decrease CO2 emissions and to sustain that decrease. A lot rely on carbon capture and storage. Some even rely on projection of populations, which are under the lowest projection of the United Nations. So there's a lot of details that is there that essentially complicates the pictures beyond the physical arguments. On the political side, it is worth noting that the Paris Agreement doesn't really mention 1.5 degrees. It says that warming must be kept under 2 degrees, and if possible, well under 2 degrees, but they don't define what's that well under 2 degrees mean. So I guess politically, this is where some of the leeway comes from.
Ella, do you have anything to add?
Yeah, I think it's important to emphasize again that every single increment of a degree matters. And yes, the science is clear that the difference between 1.5 degrees and 2 degrees is stark, and that every single additional part of a degree makes a difference. And I think personally, from my own perspective, I think having an ambitious target is really, really great. And I think it's good to frame the kind of conversation in that way, because it means that it's in our mind, it's a good ambition. But it's hard to say whether we will actually meet it, because like Nicholas says, it's physically possible, but it's really about the politics at the end of the day. It's all about probability and whether or not it will end up happening. But the more we do to mitigate our impact on the climate, the better. So I think having that at the forefront of our minds is really important, because every single ton of CO2 matters. Every single 1/10 of a degree of warming matters. So being ambitious is what we need to be, because we need to tackle this problem with huge urgency.
Great, thank you. I want to go to a question in the chat from Jonathan Whiteman, who asks, what are the major knowledge gaps in understanding the climate system?
Nice question.
Yeah, I thought so too. Thank you.
I can start if you like. So I think one of the things that this report actually addresses or presents kind of progress in is something called climate sensitivity, which is essentially how much the climate warms in response to emissions. So for every X amount of CO2 emissions, we get Y amount of warming. And we've made some progress in narrowing down what that actual value is, but there's still lots of question marks about that. I think another area of uncertainty is the kind of very complicated feedbacks between different elements of the climate system. So for example, with clouds are very complicated to understand, and they behave in all sorts of different ways in different conditions, and different types of clouds behave differently. And these effects actually can cancel each other out and compete, and they change as warming continues. So there's still a lot we need to understand with clouds and the feedbacks related to clouds. And then finally, I've done a lot of work on polar science, and there's still lots we don't know about ice sheets, ice sheet processes, how ice sheets are likely to change in future, glaciers. And this is really important because, as we've seen in one of those charts, that is related to the likelihood of these kind of low probability, high impact events, which could lead to enormous amounts of sea level rise. So these are ongoing questions.
Great. Thank you, Ella. I want to go to a question from Dimitri, who asks about the
Can I just complete Ella's answer a little bit?
Yes, thank you.
So in terms of climate policy making, I think there aren't that many knowledge gaps left for climate science. Is that the uncertainties that could be used to essentially delay action have disappeared a long time ago, essentially around the AR4, so the fourth assessment report. And there's debates each time there's a new assessment report, even among authors, of do we need a new report of the working group 1 on the physical understanding of climate science? Because I mean, kind of say the same thing, which means the language is stronger because there are more changes now because we keep warming and science improves, so confidence increases. But really, from a policy making point of view, there aren't anything starkly new in those reports. But it's important to repeat the messages because the action is clearly needed, as Ella showed. The more we warm, the stronger the impact. So it is very important to keep warming as low as we can. And secondly, the IPCC, as the way it is set up, is very difficult to change. So Stephen, you said it is a ritual, and in a sense, it has become more. So we will get another working group 1 report in 7 years. But in terms of the science and the let's say urgency of the science, maybe the way it has moved towards working group 2, which is about adaptation. So what can we do to adapt to climate changes? And working group 3, which is about mitigation. So what can we do to slow down or even reverse climate change?
Thank you, Nicholas. And one thing that I'll add here to editorialize a bit. I was one of the reviewers for working group 2, which I'll ask Nicholas and Ella to talk about for a moment. And it sounds like what might be happening in the last 10, 15 years is a shift of the center of gravity from the sort of scientific knowledge and controversy and discussion away from what's now an established consensus in working group 1 and toward the still very, very open questions in working group 2 and working group 3. But maybe Nicholas or Ella, for those who are unfamiliar with those second working groups, you could give them a bit of background on what they cover.
Yes, so working group 2, it looks at adaptation. So what we can do to adapt to climate changes. It is a working group which is perhaps more geared towards human science rather than physical science. So there are very complicated questions in terms of adaptation, in terms of, for example, social justice and also justice among countries, because the countries that emitted most CO2 are not necessarily those that will be most affected by climate changes. So in a sense, you ask some countries to adapt to changes that they are not responsible for. So there are many complicated political and legal aspects. Working group 3 is on mitigation. Here, perhaps at the interface between physical and human sciences. And here the question is how best to reduce CO2 emissions, what reductions are realistic and which aren't, and quite complicated discussion around costs of those reductions, like we've seen in the previous talk. And also a lot of assessments around the different economic sectors. For example, what can aviation provide in terms of mitigation, etc.
Great. I want to go to a question from Sela, who asks if you feel that policymakers are listening and taking these findings from Working Group 1 seriously enough. And I know that's a difficult question, so please feel free to engage with it in whatever way.
Maybe I can start, Ella, or you?
Yep, there you go.
Well, one way to answer that question briefly is to say that, as I said, the IPCC has repeated the message that the world is warming, that it is this is our fault, and that the more we warm, the larger the extremes we will experience, and that those changes are unprecedented. So that means that our societies are not ready for them. So those messages have been said at a different level of confidence almost in the first report in 1991. And now we are at 1.1 degrees warming. And if you look at CO2 emission changes, and if you put the IPCC report on that curve, you wouldn't be able to see an impact. So they're probably listening more now than they've been in the past, but there is of course a difference between listening and action. And for the moment, we're not on track to remain under 1.5 degrees. The best assessments we have is that we will probably be around 3 degrees if the promises of reductions are kept. So yes, the answer is probably no.
Yeah, I mean, I don't have very much to add beyond it has been many, many decades that climate scientists have been clanging this alarm bell. And even though, I mean, James Hansen testified in front of Congress in 1984 about climate change. The IPCC has been releasing reports since the 90s, every 7 years. And every single time, it's the same message, just said in more concrete terms. And I mean, I would say, like Nicholas, I do feel like things are starting to at least be talked about more. And it's hard to ignore the ongoing present climate impacts. So perhaps it does mean that policymakers and everybody else is waking up to the reality of climate change. But again, as Nicholas says, there's a difference between being aware of the problem and listening to the science and actually translating that into action. And I think that's what needs to happen next.
And I want to push on that a little bit, because historically the IPCC has been the subject of criticism in activist circles, where folks who will go and chain themselves to the fence of the White House to protest greenhouse gas emissions look at the IPCC and say, this performance of scientific objectivity and rationality has been more of a hindrance than a help. And obviously there are arguments on either side of that, but I'm wondering if either of you have thoughts on what has been, in sort of objective terms, the reticence of the IPCC to come out screaming and saying, we're headed toward catastrophe, please do something now, and instead give these very measured, even-keeled reports that are in really very cold language at the end of the day.
I guess the role of the IPCC is not to be policy prescriptive. It doesn't say what should or shouldn't happen. It is a cold way of looking at the available evidence. It doesn't do its own research. It's huge numbers of scientists who are gathering and collating research from across all fields and disciplines and calmly, clearly, and coherently presenting it as it is. So yeah, there is criticism that it's too conservative, but then you also get criticism that it's alarmist from both sides of the divide. So I think no matter, it just depends who you're asking. And I think actually being what it is as a kind of objective, if you want to say scientific resource, I think is actually an extremely important part of what the IPCC does, because then at least you know what you're getting. And then if, you know, it's up to policymakers, it's up to activists, it's up to whoever else who's involved in the politics to actually make those value judgments or those political decisions based on that science, which is, you know, as removed from the kind of political environment as possible.
And Ella, to poke on that a little bit, it sounds like the scientists are then sort of passing the buck, as we would say in the US. They're abdicating the responsibility. So the folks who know the very most about what's happening are saying, well, don't ask us what to do about it. That's your job.
Maybe if they have their IPCC hat on, perhaps. But I think on an individual level, many scientists are able to speak about the way they feel as a human being, knowing what they know. I mean, it's difficult. And I mean, you can probably tell from both the way Nicholas and I have been answering questions, that when you're wearing your scientist hat, as if you're a member of the IPCC, for example, if you're a scientist contributing to that, or you're related to an organization like a university, you have to be careful with what you say sometimes. But as a human being, knowing what you know, you can say from a personal level how that makes you feel. And I mean, personally, if I'm speaking as a climate scientist and as a person, knowing about the climate science, it makes me feel, you know, like I want to do everything that I can as a person to tackle climate change. So I think that it depends on what hat you're wearing.
Mm-hmm. Yeah, and interesting questions here about this sort of 18th, 19th century, 20th century paradigm of the scientist, and how that then gets translated into 21st century emergencies. And I think it's interesting, we've seen similar stuff happening with COVID-19 and the role of medical professionals and doctors in trying to also strike that balance between their sort of what they feel has to be a scientific objectivity and then the desire to get involved. I want to go to a question from Ronnie, who brings up integrated assessment models, which are, as you guys could explain better than I could, the very large sets of calculations that aggregate huge amounts of data and create fairly precise linear outcomes in terms of, well, these are the climate parameters, this is the expected warming. And Ronnie asks what the most aggressive assumptions and simplifications that are made in those integrated assessment models.
That's probably a question more for working group 3 persons than working group 1, which is more using climate models. I would say that from a political perspective, from in terms of policy relevance of the reports, the models are good enough, and we have also learned a lot about how to couple models and past observations to constrain future projections. That doesn't mean, of course, that the models represent everything perfectly. They will never do that. But they give us enough information to have a good idea of the range of possible futures that are ahead of us and how those futures connect to political choices.
I want to go to a question from Yu Zhang, who asks about attribution, which in my understanding is one of the unsettled parts of climate science, which is you take a particular event, a weather event, a hurricane, or a flood, or a deep freeze, or a heat wave, and you try your best to say, well, was this definitively caused by anthropogenic climate change? And Yuzhang asks how much these recent high-profile extreme events can be attributed. And I'm wondering if you all could speak a bit to that.
That's actually one of the area of progress between the 5th assessment report and the 6th assessment report. And it is now possible, thanks to the progress of climate science, to attribute individual events to human influence. And this is done almost now routinely by several groups in the world, one being based at the University of Oxford, actually. And for some events, for example, for the heat wave in Siberia that happened this year, essentially it was almost impossible for it to happen in pre-industrial climate conditions. So you can say that for that heat wave, it is completely attributable to human influence. For flooding in Germany and the cold weather in Texas, human contribution is also very high. It's very difficult to get this kind of events on a climate that is not modified by humans. So yes, strong area of progress between the two assessments reports here. Of course, that doesn't help solutions, but certainly it helps to put extreme events in perspective.
We have a wonderful question from Dimitri about the process of the IPCC, who asks how a 4,000-page document with 200 authors comes together. And I want to tack on a question to that as well, which is, how many people do you think have read the entire 4,000 pages?
That's a good question. So the IPCC process, so the 6th assessment report process for working group 1 started in 2018. So it's a 3-year endeavor. It takes a lot of time, and there have been 4 drafts, successive drafts that have been written, and each has received comments which have been addressed to produce the next draft, etc. So it's a massive amount of work, and for the authors, it's a very big time commitment, especially with the pandemic that moved everything online, and that made everything longer. So how is it organized? So each chapter has 2 or 3 what's called coordinating lead authors. So people who kind of take responsibility for the whole chapters, and then about 10 to 12 authors that write the different sections, and each author has kind of a section they are in charge of, depending on their expertise. And then everything is overseen by a bureau and co-chairs. So nobody really has read the whole report ever, I think, and in many sense it is not written to be read from top to bottom, or 4,000 pages. I should add that the different chapters, which are dedicated to different aspects of the climate system and of climate change, are also extraordinary resources for climate scientists, because they kind of set the level of the state of the art and of understanding, and they highlight where there are open questions.
Great. I want to ask a closing question here, and it's a sort of lightning round. And I want you all to think of one aspect of climate science or one key finding in the in AR6 that you think is most important for a particular group of people to know or most poorly understood by them. And so, for example, we'll start with policymakers. And so the question would be, what's one aspect of climate science that you think is most poorly understood by policymakers, or one thing that you would really want them to know? Ella, I'll start with you.
The potential benefit that comes with early action as opposed to the potential consequences of delaying action.
I was a bit surprised by how illiterate the policymakers are in terms of climate change. I mean, to be honest, I never really taught it. They tend to be more on the finance and the economic side of things. But essentially, they don't really know much about climate change at all, and are the physics. They got that CO2 is involved, but they have a little view of other species, for example, which is a bit of a problem because methane, for example, offers attractive options for mitigation in addition to CO2 decreases.
Great. Next question, not policymakers, but people in the media. What do you think they least understand well or need to know?
I'll let you start,
Okay.
Ella.
Can you tell by my face that I'm trying to think of how to say this? I think it's maybe not necessarily needing to know, but it's about the kind of the ongoingness of it, because I think the media tends to focus on very short kind of news events. So for example, they covered the IPCC Working Group 1 report for a few days and then it drops off the agenda. So I think the kind of ubiquitousness of how climate change touches everything would probably be something that I think could be communicated more in the media.
Yeah, I don't really have something to add. That's a great answer. It's true that media works at a pace that is a bit different to the importance of repeating the message. But one issue I would add is that climate science is a very polarizing subject, politically and socially. And depending on which media you have access to or you like to read, the subject has a very different importance. And given the global reach and impact of that problem, it is an issue.
All right, and last question. One aspect of climate science that is poorly understood or really important to know among your family?
I would say that my family are actually quite good. I think they're long suffering. They've heard a lot about ice sheets and clouds over the years. And I guess that their environmental awareness is part of the reason that I went into climate science in the first place. So for me, my family, I think, are already quite aware, but I think it would probably be the kind of the nuance, the subtle nuance. They would have the top level information, but the more nuanced processes, perhaps they might not know about.
Okay, model family from Ella's side. Nicholas?
Yeah, it was not too different. One important aspect, I suppose, and that's maybe a criticism that could be extended to many people of perhaps the older generation, is to make sure that they understand that solutions to climate change happen now. That we can't just kick the problem into the long grass and say, oh well, they will probably invent carbon capture that will be cheap and efficient in some stage in the future, and the problem will disappear, which essentially is the same as putting responsibility to the solution for the younger generation, which is unfair. So there is a little generational problem sometimes.
Great. Ella, Nicholas, I want to thank you both for taking the time to talk and for joining us. This was in a world that is filled with presentations on the physical science of climate change. I think that you guys did a really good job of getting into the nuance, and I appreciate your engagement and honesty with some difficult questions from me and from all of our participants. So maybe everyone, if we can give Ella and Nicholas a virtual or real round of applause, that would be great. Thank you, guys.